Welcome to 6WIN's new vRouter webinar, where we will present our multi-cloud vRouter solution for service providers. My name is Kelly LeBlanc. I run 6WIN's marketing program and am based in Santa Clara, California. Joining me is Jan Rappaport, 6WIN's VP of Product Management, based at our headquarters in France. Jan will deliver our vRouter product demo. Today's topic is multi-cloud vRouter solutions for service providers. We've reserved plenty of time for Q&A at the end of today's webinar. Please ask any questions that you have using the Q&A button at the bottom of your screen. We will answer them in the order that they are received. Let's get started with a brief introduction about 6WIN. 6WIN is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. Our flagship products include our 6WIN Gate source code for Linux networking and vRouters for routing and security. In recognition of our innovation, we received an investment from Cisco and a vRouter Innovators Award from IDC. For those of you from the developers community, you may know us as the founders of dpdk.org and a top contributor. 6WIN's initial flagship product, 6WIN Gate, is a complete Layer 2 through Layer 4 networking stack available in a source code form factor optimized for standard commercial off-the-shelf servers, including x86 and ARM architectures. 6WIN Gate is integrated by OEM vendors to develop a complete networking appliance, solution, or system. 6WIN Gate is also used to build 6WIN's vRouter family. The vRouter family includes software solutions for routing, secure VPNs, and hypervisor scaling. It is a family of products designed to offer a cost-effective, high-performance alternative to hardware routers and security gateways. Customers for this solution benefit from the various advantages of virtualization, such as cost savings, networking flexibility, and programmability. Here is a list of some of our key customers, many of which are brand names in the networking and applications market. OEMs such as Cisco, Nokia, NEC, Mavenir, Nuage, and many others have been using our 6WIN Gate source code to build their own products for over a decade. Service providers and enterprises such as Arbor Networks, AT&T, and OVH use our vRouters to build their networks and services. One of our most popular use cases is to help the worldwide ISP community replace their legacy hardware routers with our vRouters. We've successfully replaced Cisco and MikroTik hardware routers and Brocade vRouters with our focus on performance, features, management, and support. These deployments help our customers migrate from proprietary hardware or upgrade to higher performance software, enabling a successful transition to white box networking. In today's webinar, we will start with an overview of our vRouter. Then we will introduce our vRouter service provider solutions with a focus on our multi-cloud vRouter. Jan will give a demo of our multi-cloud vRouter solution used in our service provider customers' networks. Then we've left plenty of time for Q&A. 6WIN's vRouter is designed to be the industry standard routing software for service providers. We deliver the performance and features required to replace hardware routers with software on commercial off-the-shelf servers, running bare metal or in virtual machines. Our software scales with the number of cores in your system, and route size is limited only with memory. You can create the performance you need for any requirement. We adhere to an open management philosophy with the choice of CLI or NetConfiang-based APIs for automation. This gives you the flexibility to manage our vRouter in your existing environment without changes. Here's an overview of our features. 6WIN vRouter includes IPv4 IPv6 networking with support for VRFs, BGP OSPF dynamic routing, tunneling, NAT, PPPoE and L2TP client server, ACLs, GRE, VLAN, VXLAN encapsulations, LAG high availability, and more. IPsec VPN functionality is available through IPsec and IKE features for customers that need secure VPN tunnels and connections between sites, data centers, or mobile infrastructure. You can see our flexible options for management, system requirements, NICs, and performance, which we'll now cover in more detail. Performance is important for vRouter solutions as software and virtualization replace hardware. At 6WIN, we do benchmark tests for our customers that can be helpful when designing networks. On an Intel Atom processor, which is popular for UCPE use cases, our vRouter software performance for IP forwarding is 3.6 million packets per second per core. For IPsec, we achieve 1.35 gigabits per second per core. For use cases with higher performance requirements, such as border routers and BNGs, you can see our Intel Xeon Platinum processor performance with 12 million packets per second per core of IP forwarding and 18 gigabits per second per core of IPsec. With 6WIN vRouters, performance scales linearly with the number of cores. So if you need more performance, simply add more cores to your vRouter deployment. Here's a summary of our vRouter management, which is a critical feature for service providers. 6WIN vRouter provides both traditional CLI-based management and IT management based on Young and NetConf APIs for integration with higher-level orchestrators and management frameworks. For deployment, we provide packaged images for bare metal, KVM, VMware, and AWS, and leverage the Linux Cloud Init and Ansible features to enable customization of the system. Finally, for monitoring, we support the traditional SNMP and syslog mechanisms, plus data plane telemetry through SFlow and graphical analytics with time series database. 6WIN's vRouter allows you to build a range of solutions on commercial off-the-shelf servers with the same software. We support a range of powerful Intel CPUs from the Atom processor all the way up to the latest Xeon scalable processors and 1 to 100 gig NICs. Many of you already have servers from one of these leading vendors, so you're ready to go. Just download our software and you can have a router with 1 to 100 gig of throughput performance according to your requirements. If you are purchasing servers for your deployment, you have a wide range of options and flexibility for bare metal and virtual machine deployments. We license our software with 1 gig to 100 gig options. For our vRouter, in addition to our multi-cloud solution, we have many other use cases where our customers replace hardware with software. A leading example is our border router use case where we've replaced hardware border routers with vRouters. We have many ISP customers who have successfully made this transition, including our latest IXP customer, PIT US and PIT Chile, who service 10 million users in over 80 ISPs. Our security vRouter use cases are popular because we allow customers to replace security gateways and IPsec VPN solutions with vRouters. UCPE, BNG, and SDN vRouters are emerging use cases as well. We also deliver our vRouter software and source code for customers that want to build their own solution. This has been very popular for emerging 5G use cases. Now let's focus on our multi-cloud vRouter use case with a live deployment. Sovereign, which provides services to more than 25,000 independent online publishers, selected 6WIN vRouters as an alternative to the Brocade vAuto vRouters that it was leasing in a software-as-a-service model from SoftLayer. Upon receiving the end-of-sale and end-of-support notification for Brocade's vRouters, Sovereign evaluated 6WIN's vRouters and found them to be in a drop-in replacement. With 6WIN vRouter, Sovereign exceeded its 5 gigabits per second throughput metric for BGP, firewalling, and IPsec VPNs when testing traffic from data center to AWS. For monitoring, Sovereign gains system health information through traditional SNMP and syslog mechanisms, plus telemetry through SFlow and graphic analytics with time series database, including pre-integration with Grafana. With 6WIN vRouters, Sovereign now has its own solution to route and secure traffic between the sites and data centers that give publishers the products and services needed to create and grow their audience and business. Now let's look at our MultiCloud vRouter solution in more detail before our demo. Many companies now host services on different cloud platforms such as AWS, Microsoft Azure, Google Cloud Platform, and Salesforce. We will share a demo on how our vRouter can help cloud service providers manage connections, routing, and peering to service their customers. A single vRouter instance can handle more than 100 customers, and each customer's virtual routing function is configured according to customer requirements. It is a very scalable and flexible solution. I will now turn it over to Jan for our demo.
Thank you, Kelly. So in this demo, we will show you a vRouter running in the multi-cloud service provider network, providing cloud connectivity to customers. We will start with customer A, who is connected to the 3 cloud services, Azure, AWS, and Salesforce. We will review the vRouter configuration using the CLI. We will see how customer A is isolated in its own VRF, how it is connected to the customer network and the clouds using VLANs and BGP, and how QoS is used to ensure the customer's SLA. We will also demonstrate how the customer can be monitored using a time series database and a graphical analytics with InfluxDB and Grafana. Then we will add customer B, this time configured using Ansible and netconf to demonstrate automation. We will show how customer B can be monitored in its own dashboard. And finally, we will show a third generic dashboard for general monitoring of the vRouter. Let's switch to our demo. Let's start by reviewing the configuration of the vRouter for customer A using the CLI. Each customer is configured inside its own VRF. This maintains isolation between customers. We can see the VLAN interfaces used towards the cloud services on one side and the customer's network on the other side. This customer is connected to Salesforce, AWS, and Microsoft Azure. QoS is used to enforce the SLA subscribed by the customer. In this case, 1 gig of bandwidth is configured globally on the VRF. However, of course, more performance can be configured. As we showed in our customer Sovereign's use case, Sovereign exceeded its 5 gigabit per second throughput metric for BGP, firewalling, and IPsec VPNs when testing traffic from data center to AWS. Let's now review the routing configuration. A BGP peer is configured with each of the cloud services and with the internal customer network. Route maps and community lists are used to configure route redistribution so that link local addresses and routes belonging to a cloud service are not duplicated. We can now check the routing state in the VRF. We see the route in 1091 towards the internal customer network and the routes in 172.16 towards the 3 cloud services. Let's now simulate some traffic between the customer networks and the cloud. We start a traffic capture on the VM emulating the cloud service and we launch a ping from the VM located on the customer's network on the other side of the vRouter. This will use the routes learned through BGP. While the traffic is running, we can review the configuration of the KPIs that are retrieved from the system. These include product information, such as license and version, system information, such as CPU or memory usage, networking statistics, and others. These KPIs are periodically exported to an InfluxDB time series database and will be displayed in a Grafana dashboard. In the dashboard for this customer, we see the RX and TX throughput of each interface. This includes instance throughput in a gauge and variation over time as a curve. On the top, we see the VLAN facing the customer network, and on the bottom, we see the 3 VLANs towards the cloud services. This is a simulated environment focused at showing functionality, so the throughput is quite low here. Let's now configure customer B on the vRouter, this time using Ansible and netconf. On the management VM, a simple Ansible playbook is configured to apply a netconf configuration described in an XML file. A quick review of the XML configuration shows us it is similar to customer A's, including a VRF, QoS, routing, and VLAN interfaces towards 2 cloud services and the customer's internal network, and of course KPIs. We execute the playbook and are now ready to review the configuration of the customer in VRF2. Using the CLI, we can see as before the BGP configuration, the VLAN interfaces, the QoS, and the KPIs. The BGP state includes the 1091 internal network towards the customer's LAN and the 172.16 networks towards the cloud services. As previously, we can capture traffic on a cloud VM and ping from a VM on the customer's network. In Grafana, the dashboard for customer B is very similar to the one for customer A, except we only have 2 interfaces towards the cloud services. As before, we see the RX and TX throughput of each interface, including instance throughput and variation over time. We have seen the 2 dashboards that the service provider will expose to each customer. To conclude, let's have a look at the general dashboard used by the service provider to check the status of the vRouter. We can easily see system uptime, vRouter status, memory and CPU usage, network interfaces with their throughputs, process and users information, disk usage, and IPv4 neighbors and routes configured in the system. It's all available in a single, easy-to-use dashboard, which is important as we allow service providers to manage over 100 customers per vRouter. So this concludes our demo. The demo platform was focused on demonstrating functionality. In a real use case, the 6WIN vRouter for multi-cloud service providers scales from 1 gig to more than 100 gig of connectivity, can support more than 100 customers per vRouter, leverages an extensive feature set, including the VRF, BGP, and QoS features we have demonstrated, supports the netconfig API for integration with automation tools such as Ansible and customers' orchestration systems, and provides telemetry for advanced monitoring and analysis by streaming KPIs to a time series database, which can then be displayed in a graphical tool. In our demo, we used InfluxDB and Grafana, but others are possible. It's a very scalable, flexible solution and easy to use. This is why customers like Southern have been having tremendous success with our vRouter. Thank you for watching my demo. I will now turn it over to Q&A.
Thank you, Jan. That was a great demo. So we've reserved plenty of time for Q&A. This is your chance to ask Jan your questions about our vRouter. So as a reminder, You can ask your questions using the Q&A button at the bottom of your screen, and we'll answer them in the order received. We have received a couple, so let's get started. Okay, first question. What platform did you use for your demo?
For this demo, we used a fully virtualized platform because we wanted to demonstrate functionality. So everything was running as many VMs on a big server. But actually, the same demo could be run on, for example, an Intel C3000 for low performance requirements, up to an Intel Xeon Scalable Platinum processor for higher performance requirements. Actually, our data plane performance scales with the CPU cores, and the control plane performance scales with system memory. So you can build a range of solutions according to your requirements with exactly the same software.
Okay, thank you. So let's go to the second question. Have you integrated your vRouter with any management frameworks?
Sure. So we have a strong history with our tier 1 service providers customers who have integrated our vRouter with their custom management framework. Customers such as Southern, as we have seen, benefit from our netconfig-based APIs for integration into their existing systems. And also for monitoring, we have shown InfluxDB Grafana as an example. We have done integration with Nagios for more basic monitoring based on SNMP. And regarding orchestration of the systems, we have done integration with VMware, OpenStack, OpenDaylight, so both open source, but also commercial versions like the ones from Cloudify. We have integrated also with Nuage and Contron, who are good partners, etc.
Excellent. Next question. Do I need a specific license to deploy in virtual machines?
No, you don't, because it's pure software. Our vRouter supports bare metal or VM deployments, and this with the same software license. We support, for bare metal, we support installation using PXE, ISO, and USB. And for VMs, we support OVA for VMware. We support QCO2 for KVM deployment with Cloud Init support. We support PCI pass-through, SRIOV, VirtIO, VMXNet 3, and AWS NICs, the ENA NICs for Amazon. And all this is included in the same license, in the same binary.
Okay, fantastic. So that's all the questions that we can see right now. So if there's no further questions, thank you, Jan, for answering the questions, and thank you all for your questions and for your attendance. This concludes our Q&A and our webinar. If you would like to evaluate our vRouter, please simply fill out the evaluation form on our website at 6wind.com. You can also write into us at any time and ask us any of your further questions. We look forward to hearing from you. Bye for now.